Hello everyone. How are you all? Okay, so today we will discuss calculus. So I have seen that you guys are facing a bit of problem in calculus. So we will make sure that you understand everything. Okay. So today we are just going to solve many questions actually, just from the limit and continuity. If time permits, then we will also go to the differentiability. So there are a few slides that I prepared just to make sure that you understand everything in the differentiability, especially that how these all the things are making sense geometrically. Okay, so if you have already seen the previous lectures, then it is fine. The previous lecture, which means the last year lecture that I have uploaded on the YouTube, if you have already seen, then it is fine. Otherwise, don't worry. Like we will be covering almost everything from the scratch. Okay, so let's just get started with the definition of limits. So before that, let me know if everything is fine. Audio, video, everything is fine, right? Okay. Cool. ठीक है. Thank you everyone. Okay, let's just start. So we will be starting, as I said, with the definition of limit, and then we will be solving many questions just in the limit. Okay. So let's just start with the definition of limit. So what is a limit of any function? So suppose that there is some function which is given to me. So mathematically, I represent a function by fx if the function is in x. Okay. Although it is very obvious that this function is scalar, right? So can anyone tell me whether this x here in our course that we talk about, this x is scalar or vector? Okay. So this is also a scalar, right? Although like you will be seeing later in your masters that you may be having a function of vectors. For example, like currently, obviously, I'm not going over it, but let's suppose you have a function of any vector v, and then this could be v into v transpose, something like this, right? Or v transpose into v, if there's a column vector. So let's suppose this v is a column vector. So this is v, and this is v transpose. Now, can you tell me whether this V transpose into V, this FB is a scalar or a vector? No, this FB is a scalar, right? This FB is a scalar, but input here is a vector. So this is actually the machine learning thing. In the machine learning, you will be seeing these kind of functions. So generally, like we have a loss function in machine learning, and the loss function is basically the scalar number, but it takes the vector or the matrix inside it. Okay, and then final quantity is scalar, but we will see it later. Yeah, you call it 1 into 1 vector or you call it a scalar, it is just by the definition, it doesn't matter. Okay, anyway, so here we have everything is in the scalar. So here we have a function which is fx. Now obviously the x is scalar and f is also scalar. I mean the fx is also scalar. So any function fx we have, let's suppose, then we say that limit exists whenever if I go to this a, let's suppose limit exists as a, if I go from the left side and from the right side, and both the values are same. Now, which means what? That if you go to the a from the left side, then let's suppose this value is anything, maybe L. So if you go to this a from the left side, then this function is approaching to which value? This function is basically like, if you are I hope you are getting my point. Maybe I can just draw it a bit more clearly. See, what I mean to say is something like this. Suppose that you are here. Okay, you are here, which could be any point, maybe a minus 3, and then if I say that if you go from a minus 3 to a, then I mean if you approach to this a from the left hand side, and the left hand side means any value which is smaller than a, which means if you approach this a from the left hand side, then the function is approaching to this value, and let's suppose this value is L. Okay, this value is L, and if you approach this function on the right hand side, then function is approaching to this value, the same value, isn't it? So basically, if you approach this function from the left hand side means that you come from the left or you come from the right, the function is approaching to the same value, and that's where we say that limit exists. So basically, mathematically, like we can define it something in this way: the limit x tends to a minus means you are going from the left to this fx, the value of fx at a minus. So which means which means can anyone tell me like what does this mean? This means f of a minus h, right? The value of f at a minus h. Okay. See, whenever I'm saying that this function, the value of f at like the value of f whenever you are approaching from the left side, which means the value of f at a minus h. Is this okay to everyone? But here, just one technical thing that I have missed. And what is the technical thing? Age any number, age any number, age any number. I want to represent, see, okay, let's do it a bit more clearly. Suppose I want to, I have an English statement, okay? Suppose I have an English statement which says like this, the value of function the value of function when, okay, just tell me the value of function at a. What is the value of function at a? fa. fa, right? Okay, don't worry about this graph. Sorry, don't worry about this graph. I'm asking you in general. I'm asking you the general. What is the value of function at a? At any point a? This is fa, right? This is fa. Is this clear to everyone? The value of function at any point a is fa. It may be defined, may not be defined. I mean, I'm not 100% saying that that fa will be defined, which means like maybe you have 1 upon x, and if I just ask you the value of function at x equal to 0, then so it is infinity, but infinity is not a number, right? Infinity is not a number. You can't say like, I mean, it is any number. So that's why you can say either you can say not defined or you can say infinity, doesn't matter. I mean, you can say infinity here, but by default it means that it doesn't have any interpretation. I mean, it is not a number. So basically what I'm saying, or it may not be even defined. See, in this case it is infinity, but maybe that x equal to 0 is not in the not even in the domain. Okay. So but if I say that value of the function at a is fa, maybe may exist, may not exist, maybe infinity, maybe 0, maybe any number, but it is fa. Okay, like we are just writing in the abstract way. But if I just ask you the value of the function near to a, then what is the answer? The value of function very near to a, it is f a plus h or f a minus h. I mean, whatever. If your near means that you are coming from the left or you're coming from the right. Is this clear to everyone? I mean, I have to define whether I'm coming from the left or I'm coming from the right. If I'm coming from the left, I will say that this is f a plus h. If I'm coming from the right, I will say if it is f a, sorry, if I'm coming from the left, a minus h, coming from the right, then it is a plus h. H is the distance covered on the axis. Yes, h is the distance. Yes. So basically, this is the point A. This is the point A minus h. This is the point. Okay, sorry. This is the point A plus h. Okay. So h is the, yes, h is basically some x distance, you can say. Is this okay to everyone? So if you are coming from the left, it is, yes. Saurabh, it's a nice point. I will come to that. So if you're coming from the left, you are basically talking about a minus h. If you're coming from the right, if you are basically talking about a plus h. But here, whenever I say that near to a, okay, whenever I say near to a, I always mean in the neighborhood, which means it is so near that you can't even visualize from your eyes. Meeting is disconnecting and again resuming. Is this happening with everyone, or this is just for Rishikesh? Okay, maybe okay. Your internet might be a little slow. That's why it is happening. Okay, cool. So this is a minus h. So whenever I say that I'm coming from the left, it is a minus h. Now let me just make it very clear. See, let's suppose there is some function, okay, whatever it is, and this is a. If I just ask you that what is the value of the function near to a, then do I mean this near, or do I mean this near, or do I mean this near? If I just say the value of the function near to a, the third one, right? I mean the very, very near. Okay. Which means we always talk about in the neighborhood. Either it is limit, or it is continuity, or it is differentiability. We always talk in the neighborhood. Okay. So in the differentiability, we will see the local minima, local maxima, these kind of things. So basically, we never know the future. If I'm at the A, I don't know the future in the sense, or the past. Basically, I don't know. I don't know two past or two future. I try to be just in the neighborhood, and based on that, I talk about something here. Okay. So I say that limit exists if I'm coming from the left, or I'm coming from the right. It is basically almost same. Now just see this. If you come from the left, then what is the value? This is the value. If you come from the right, what is the value? This is the value. Is it okay to everyone? Right? I mean, these are the 2 points. But you can't you can't even imagine that these 2 points are extremely close. This is so close that you can say this is just A. Okay, these are so close. So if you put a microscope on this, then you will be able to see that this is what I'm talking about. Okay, this is A plus A minus H. This is A minus H, and then this is A plus H, which means I mean, these are extremely near. These are extremely near point. Okay, here, if I'm saying that near to A, then I'm talking about A plus H or A minus H. That is okay. But one thing is also left to mention. And what is that thing? That H must be 0. H must be tending to 0. Yeah, H is very, very small. Okay, so whenever I'm saying the near to A, it means that I'm talking about A plus H or A minus H, where H is extremely small. It is so small that it is almost 0. You can say it is almost 0. Okay, I mean, you can say it is 0.0000000000001, something like that. Okay, H is something like that. It is very, very small. Okay, cool. So I hope this, at least this thing is clear, that what do I mean by saying that it is near to A. Okay. Now, if I'm saying that if you come either from the left, which means you talk about this point, which is A minus H, or you talk about this point, which is A plus H, then at both if you either come from the left or you come from the right, then at both the point, the function is leading to the same value, which is L. Okay. Function is approaching to the same value, which is L, which means that it is not the case that if you come from the left, maybe I can draw a different diagram. See, okay, sorry about the drawing, but it will be a little bit clear. See, here, suppose if I have this kind of function, can you tell me, let's suppose this is any other value, maybe R. Okay, can you tell me what is the value of the function? Visually, I'm just asking you, don't go any mathematically. Value of the function at A minus H when H tends to 0. This is L, right? Which means if you come from the left, it is L. But if you come from the right, if you go from the right, if you talk about this point, and what it is in that case, f of A plus H, limit H tends to 0. This is R. Which means if you're coming from the right, it is something else. If you're coming from the left, it is something else. Right? So basically, this is what the limit means. If the both things are different, which means it is drastic change. Drastic change means, मतलब लेफ्ट में देखा तो L था और राइट में देखा तो एकदम से R. मतलब it's like, okay, I can remember a meme here. Do you know that cricket meme कि एकदम से जज्बात बदल दिए, वक्त बदल दिया, right? So that kind of meme you can relate. So basically, this is, if it is not happening in that case, which means that if it is not happening that you go left and you go right, and things are at least मतलब almost same, which means things are L. If you either come from the left or you come from the right, then you will say limit exist. But if you see a drastic change at that particular point, then it means that limit does not exist. The function being discontinuous will look like this. Yes, function is discontinuous. It will be, yeah, it is discontinuous here. So here, can you tell me what is the value of fa? What is the value of fa? Okay. Let's suppose it is not defined. Okay, which means the value of fa, I'm not that a is not even in the domain. But suppose the value of fa is L. The value of fa is L. Then tell me the limit exists or not. Which means a minus h is L. I agree. And fa is also L. Then tell me limit exists or not in this case. Right? So in this case also limit does not exist. Why? Because you coming from the left, you are seeing L. You coming from the right, you are seeing okay. You are seeing something different. So that's why limit does not exist in this case also. Which means what is the value of fa? Whether it is defined, not defined, does not matter for the limit. Is this clear to everyone? Okay. Which means you come from the left, it is L. You come from the right, it is R. That's the only thing which matters. What is the value of that particular point? Yeah, it does not matter. Value of fa does not matter for the limit. Okay. So it does not matter here. Now suppose the fa value is instead of L, let's suppose this is R, which means I say that if you come from the right or you talk about that particular point, then this is same as R. Then tell me limit exists or not. Here also limit does not exist, right? See, the value of fa does not matter. What matters that if you're coming from the left and if you're coming from the right, both are same or not. If both are different, then limit does not exist. Okay, cool. So basically in this case, limit exists because you coming from the left or coming from the right, both are approaching to the same value. But in this case, limit does not exist. Okay, so let me, okay, before solving the question, let me just quickly go over the earlier notes. Right, so that's where we talk about the limit. I hope this is visible, right? Just a second. Yeah, okay. So when x approach to a, what is the value of fx, right? So this is the mathematical notation of notation of limit. So fa may or may not be identified, may or may not be defined, but I can say the left hand limit is basically something like this. Like if we are approaching from the left, then this is called left hand limit. If you're approaching from the right, then this is called right hand limit. And if both are equal, then you will say limit exist. Okay. So I hope this is clear that if both are equal, then you will say limit exist. So left hand limit, right hand limit, and LHL is equal to RHL, then you will say limit exist. And what is left hand limit? You will say limit s tends to 0. You are coming from left hand side. Limit s tends to 0. You are coming from right hand side, right? Okay. Now in the limits, you will be often encountering the questions which will be having some indeterminate forms, which means these forms might not be directly solvable, but you have to apply some trick and then you have to solve the questions. See, in the calculus, on average, I think if I remember correctly, then they have asked just 40 questions in the calculus in last 42 years or 40 years. So which means on average, this is just one question they will be asking. And that question will also be easy. It's not like the question will be tough. Like even if you do all the PYQs, then you might have got to realize that questions are not tough from the calculus. Okay, so you should be able to do all the questions after this live class, at least for the limit and continuity. Let's just see. So you will be often encountering these kind of limits, these kind of forms. Now, one thing is worth noting here is that here this, okay, first can anyone tell me this 1 power infinity, why it is not 1? Why we are saying it is under in determinant form? Why 1 power infinity is not 1? Yes, because this is not even 1. Okay, this is, see, we will be seeing the forms like 1 power infinity, infinite power 0, or like this, but these are not 1 and 0. These are not exact 1 and 0. There will be some function which will be approaching to 1, right? Which will be approaching to 1. This is not the real one. This is some function which will be approaching to 1. Okay, cool. Now we will see few methods using which we can solve these forms. Okay. Now, one of the most popular method is okay. We call it. Can anyone tell me the pronunciation of this? I think the H is silent, right? L'Hopital rule. Okay, L'Hopital. So this is a French name, and if I remember correctly, then this H must be silent. And if I remember also correctly, then this L is for the article that we have the, right? In the English we have the, and I think they use L there in the French. Anyway, and H is silent in the French rule. So this L'Hopital rule is actually very, very popular. So we will see that. Now, as I told you that these are the few forms, and there are few methods to solve them. So let's just see a few of the examples. Okay, I will quickly go through the notes, and then we will be solving the new examples in today's class. So suppose they ask you something like this, some questions like this. Okay, this is hospital, or I think S is also not there. Okay, by mistake I have written S. Maybe you can check it out. Maybe it is L'Hopital only. पता नहीं, कभी कभी शायद ऐसा होता है, नहीं होता. You can just see check this. Okay, yeah, S is not there, right? Yeah, it is L'Hopital. Cool. Okay, so let's just see a few questions. Let's suppose this is the question that is given to us, and if you put the limit 1, then can you check that this is 0.0? It is 0.0, right? So since it is 0.0, that's why you should be applying some trick here to solve it. Now, what you can do, you can, I mean, this is just one method which we might not be using ever, most probably, but this is a factorization method, which means you can basically factorize this. If you know the formula, then you can factorize this. Like for example, if you factorize this x cube minus 1, it will be x minus 1 into x square plus x plus 1, and then you can cancel out. Now the remaining, if you put the x equal to 1 in the remaining term, then it is not any indeterminate form, and which means that you can directly solve this. And 3 is the answer here. Okay. Cool. Now the second question, similarly, you can just factor it out. I mean, if you know the formula, you can do it. Otherwise, we might not be needing this particular method. Okay, this is just for the sake of completion. Yeah. Now let's just see this question. This question is dealing with the rationalization, which means that if you have something like this, and then you can see the possibility of the rationalization, which means if you can see that, okay, if you multiply the opposite of this, which means instead of minus, if you multiply the plus, then you are having the simpler form. Okay, and then you can solve this question. So these are the few tricks that we have shared in the lecture. And these are the few limit rules that if you have any limit, then you can you can do plus minus, which means like you can take this limit here inside the plus minus. It doesn't matter. You can take inside this multiplication, which means you can just multiply separately. You can also divide separately, provided that after dividing separately, m is not 0. Okay. So these lectures, everyone has seen that, right? So this was like a crash course, you can say. Okay, don't worry, we won't be using much of those lectures. Just I'm going through the slides. So similarly, if that is in a power, then also you can do it. That is a composite function, then also you can do it. You don't need to remember those nitty-gritty details that, okay, if that is in the power, then this has to be greater than 0 or something. Like GATE doesn't ask you to do to remember all of these in the calculus. So just know the basics of this. Okay, cool. So these are the few frequently used limits. It is best if you remember these limits. So at least the sin x upon x, this is limit x tends to 0 equal to 1. So I have not provided an exhaustive list. Otherwise, like there are, I think, many formulas, but I have just provided whatever is required for GATE. Okay, so sin x, actually for the GATE, you might not be needing any tan x, cot x, cosec, or these kind of things. Like GATE in the GATE trigonometry is not in the syllabus, you can say. So basically, they have limited themselves to just sin and cos. That's all. That's what my observation is. Okay, so you don't need to basically remember all the formulas regarding that trigonometry and all. So just remember these 2-3 formulas which are very frequently used. Okay, so let's suppose you want to solve this. Then what we did, we have, I think, just factor it out, and then we have used the standard limit, right? So that's how we have solved this question. Now, similarly, suppose you want to solve this and find the value of p plus q, then how we did it. So this is same as, see, e power x minus 1 upon x is 1, right? So you can say here, from here, that this e power x minus q upon x. So q must be 1 to make it 1, and then p by 2 is also 1. right? Okay. And now we have seen the infinity upon infinity form. In this case, particularly, we generally have the polynomials only. So which means that we will be having the polynomials. And if above is a higher polynomial, okay, which means that if above is n cube and below is just n square, then the answer will be infinity only, right? If above is lesser, which means n square, and below is greater, which means n cube, then answer will be approaching to 0 or some good answer will be there. Okay, finite. Yeah. So infinity upon infinity form occur in most of the case of the polynomials only. So we have seen few examples that limit n tends to 0, that how to solve this. You can basically cut down the most, you can take the common, you can take the power common, which is the highest power. Do you remember this? This is fine, right? Okay. Is this fine to everyone that you have to take the highest power common? Okay. Similarly, here also you can take the highest power common and then you can solve this. Now, infinity minus infinity form, this kind of form may occur. And in this kind of form, can anyone tell me what is the main trick that we apply? What is the main trick? Yes, we try to combine both of the functions, right? If infinity minus infinity kind of formulation is there, we try to combine both of these functions. Is this okay to everyone? Okay. So basically here, if it is infinity minus infinity, then how you can combine? You can take this LCM and then you can convert this infinity minus infinity to infinity upon infinity, which means in the 0 upon infinity, infinity upon 0, or something like that. I mean, in that kind of form, you can convert in that kind of form, right? Okay. Yeah. So yeah, somehow you need to basically convert this infinity minus infinity into other form. Karan is saying, Karan, have you seen these videos? So let me just do one thing. Let me just take this example: x square minus x square plus 2x minus x. So limit x tends to infinity. This is x square plus 2x minus x, right? You want to solve this. So as you notice that this is infinity minus infinity. So how to solve this question? You can't actually directly solve. There must be something. You need to convert that to a infinity upon infinity or 0 upon 0, something like that. So what you can do, you can rationalize here, right? So you can multiply by x square plus 2x plus x upon, just a second, upon x square plus 2x plus x, right? So what will the answer? It will be x square plus 2x minus x square upon square root of x square plus 2x plus x, where limit x tends to infinity. Is this okay to everyone? Now you can just cancel this out. It will be 2x upon square root of x square plus 2x plus x, limit x tends to infinity. Now you can see this is infinity upon infinity form. So how to solve infinity upon infinity form? You can take the highest power common. You take the x common from here. It will be 2. So maybe I can go to the next page. So this is 2x upon square root of x square plus 2x minus, plus x. And then what you can do, you can take x common from here. So from here you can take x square common. So it will be 1 plus 2 upon x, right? So 2x divided by, you can take x square common. And then if you take the x square common, automatically x will come out only, right? Automatically only x will come out. Is this okay to everyone? This is square root of 1 plus 2 upon x. And then you can take x common from here also. It will be plus 1. Is this okay or there is some problem with this? Let me know. Okay. So you can cancel out x and x. You can put x tends to infinity here, which will be 2 upon square root of 1 plus 2x plus 1. Then it will be 0. It will be 1. 1 plus 1, 2, right? So it is, the final answer is 1. Okay. Cool. By the way, you know, right, that you can replace this x tends to infinity by any other variable, right? Let's suppose you put x equal to 1 upon y. Can you replace this x tends to infinity by some other variable, y? So suppose you have something like this, okay? Suppose limit x tends to infinity, anything, maybe 2 upon 1 plus 2 upon x plus 1. If you want to replace this x tends to infinity by some using some relation x equal to 1 upon y, then it means y tends to 0. If x is going to infinity, which means y is actually 1 upon x, which means y tends to 0. So wherever you are writing the x, you need to write the y, but you need to properly fit the limit. Okay, so this is 2 upon 1 plus y square root plus 1. And if you put y equal to 0, then again it is just 2 upon 1 plus 0 plus 1, 2 upon 2, which is just 1, right? So basically you can also replace the limits. That's what you know. Okay. Now we have solved one more question. Yeah, this is also a good question. So here they are asking about the values of a and b. So I think these questions I have taken from 12th class notes. I mean 12th class reference material. So there only they ask these kind of things, if you remember, right? Okay. Now let's just see one of the most important. I don't know important or not, but I can say one of the most nice form, which is 1 power infinity. Were you able to understand that that particular form in the lectures? This is the last slide, I think. Okay. So let's just see this. Okay. Maybe I can just write it here. What do I mean by that one power infinity form? Let's suppose there is just some function. Okay, there is some function that is going to I mean either 0 or 1, but let me just write in that way. Suppose this is something like this. Now suppose fx is going to gx is going to infinity and fx is going to 0, right? If fx is going to 0, then it will be 1 power infinity. Now do anyone remember what should I write? What should I be writing here? X tends to 0 or infinity? Do I care about it? I don't know, right? So should I be caring about it? See, I mean, it could be 0, doesn't matter. But at the same time, these should be going to 0 at the x tends to 0, right? Limit x tends to 0 or whatever it is. If it is a, then it is a, basically. Okay, which means if there is a limit, which is something like this, wherever this, I mean, in this particular question, what is happening? This fx is going to 1 at this limit. Sorry, fx is going to 0 at this limit. At the same time, gx is going to infinity at this limit. Then it is called 1 power infinity form. So this is a 1 power infinity form because this is 1 power infinity. And we want to solve this kind of question. Okay. So let's just solve this. Do you remember the direct formula? Yeah, this is a. So you can have a, I mean, or 0 or 1, doesn't matter. So limit x tends to a, 1 plus fx power gx. Here fx is going to 0 for x going to a, and gx is going to infinity for x going to a. So this is what we want to solve. This is one template. Template की spelling सही है क्या? Or it should be template? Okay. Cool. So how we can solve it? Okay. Before that, can anybody recall me direct formula? So what is the direct formula? It is e power I mean, what you can do, you can just rewrite this. I mean, there will be limit x tends to a, that will definitely be there, but you can rewrite this to e power gx into fx into gx. Should I be removing this limit x tends to a? Obviously no, right? Yes. ये सही है ना? हाँ. So basically it's just like you are taking this out and then you are doing this. Okay. Let's suppose you have, okay, just out of nowhere, I'm just asking you, let's suppose you have some number n. Can you rewrite this number as e power uh, log base en? You can rewrite, right? I mean, that's what we have already seen in the fundamental videos. Okay. So if I just ask you that, actually मुझे खुद को नहीं पता, पर मैं देख रहा हूँ कि if that is making any sense. Can I write it something like this? Yeah, n should be positive. Yes, I agree. So can I write it e power log base e? The same thing here. I mean, rewriting. Okay, I'm not doing anything. I'm just rewriting the things. And then I can take this gx down. Okay. Something is wrong or everything is fine? Everything is fine till this point, right? Okay. So I can take this gx down. Cool. But this is not what we are getting, right? I mean, this is not what we are getting. Let's not worry about the corner cases, which means this should not be 0 or 1 or something like that. So we have just got this log base e 1 plus fx, right? We have just got this. But we proved something else. What we proved? We proved that this quantity is not this. This quantity is fx. I mean, e power gx into fx, right? This is what we proved. Is this okay to everyone? Matlab, this is what we have just got. This is what we have just got. Yeah, I will come to that. This is what we have just got. But answer is something else. Answer is this. E power fx into gx. So are we doing something wrong? Let me know. Are we doing something wrong? So why we are not getting the same answer as earlier? Earlier we got, because till now it's a general thing. I mean, I have not used anywhere I have not used the property that fx is going to 0 or something like that and gx is going to 1, gx is going to infinity or something like that. Have I used somewhere any like these kind of properties? I don't think, right? It is just a general number. It is just a general number which I'm just writing something like this. So till now I have not used any property, but can I use? Why not, right? So basically this is what is given to me, which is limit x tends to a 1 plus fx power gx. This is what is given to me. Now what I'm doing, I'm just rewriting it. Okay, just not doing anything. Okay, not doing anything. Rewriting to limit x tends to a e power gx into log 1 plus fx. Let me know if there is any issue till this point. Okay, we can do this, right? Yeah. Now, do you recall that what we can do? We can basically see this is just like a composite function. I mean, you can basically put this limit inside also, right? So basically, you can write this something like this. I mean, you can definitely put this limit inside. And since it is multiplication, what you can do? You can again just write it in the, yeah. Sorry. Right? Since it is multiplication, you can write it 2 times here also. Now, as you can see that this particular thing can be written as, just fx. Can anyone tell me how? See what I'm saying, that limit x tends to a log of 1 plus fx, right? What you can do, you can just from here, you can just multiply and divide by fx, right? So from here, you can say, let me just multiply and divide by fx. Now, as you know, there is a standard limit which says that limit x tends to 0. I mean, if this function is going to 0, so basically log of 1 plus x upon x, limit x tends to 0. This particular formula says this should be 1. Is this okay to everyone? What does this mean? This means that if this is going to 0, or and this is also going to 0, then this log is also actually 1, right? So since fx is going to 0 at x tends to a, is this understood to everyone, or should I tell in more detail? See, what does this formula mean? This formula means that this should go to 0 and these two should be same, and this is also going to 0, right? So here this fx is going to 0, this fx is going to 0. Aren't these two are same? These two must be same, and these two must be going to 0. That's what it is saying. In that case, you have this as 1. So this is actually 1, which means now I have used the property where I'm saying that this fx is going to 0, right? So then I have used the property. Cool. So finally, I can say, sorry, that this particular thing is nothing but fx only. I mean, limit x tends to fx. Then you can combine the limit, and then ultimately it is just like e power gx into fx, right? Limit x tends to a. Is this kind of proof is understood to everyone? To be honest, this is the first time it clicked in my mind, and we just derived it. So I mean, it was not planned. Like I also don't know. I haven't known that. Okay, this is how also we can drive it. Yeah, so we were lucky actually. So I was just trying out. So it just click in my mind that okay, like why click in my mind? Because of the pattern. Like I have seen that okay, some number and you are introducing e, and actually when we see the algorithm at that time, in the time complexity kind of thing, if I want to compare, let's suppose n and e power n, then instead of comparing directly, maybe I can just write this n as e power log base en, which means I will be, if some function in case of time complexity we will be doing it, but I'm quickly telling you, let's suppose there is some function, but if I want to compare these 3 functions, okay, in case of algorithm time complexity, where some function is power of e, some function is just normal, then what we will be doing, we will be writing every function in the power of e. I mean, this is just one of the way. Okay, so that we can directly compare, and then we will be, instead of comparing these, we will be comparing these things. Okay, this is what we will be doing in the algorithms later. So from there I know that okay, actually I have not forgotten this property that we can write any number n as e power log n, something like that. I have not forgotten that property. From there I actually, that property was in somewhere in my mind, so that's why I was able to recall that property here also, and then we have just applied this anyway. So that's how you can do it, right? So basically this is just one derivation, but there are obviously other derivation that we did, but now we are not going to perform any other derivation. Let me directly write the formula. So what is the formula? If you have limit x tends to a fx power gx, which means here fx is going to fx is going to 1, gx is going to infinity, and for actually limit, you can say x tends to a. In that case, what you will be doing? You will be doing e power gx into this fx minus 1, right? Whatever function was. Earlier it was 1 plus fx, that's why it was just fx. Okay. And then this is limit x tends to a. Okay. So now let's just solve many questions using this particular formula. So actually in GATE also they have asked, that's why I'm saying this is little important. So here, as you can see that this is 1 upon infinity. So you can take this 1 upon x outside and then all, right? So let's just now go to our slide and let's just solve few of the questions. So this was just a revision. Now let's just solve this question. Can you solve this question? What you are getting here? Okay, yes, it's a nice approach. I can take x square common. Then it will be 1 minus 9 upon x square. But I think directly also you can put 1, right? Achha, it will be 0. Okay. 1 minus 9 plus x square. It is 1 plus 2 upon x minus 3 upon x square. Yeah, right. And now you put x equal to 1. Is this helping you? I don't think it is helping you, right? It is not helping you. Okay. Yeah. L'Hopital is one way. What else? Can you factor this out? Let me check if they have done using the factorization or not. Yeah. X plus 1 and x minus 1 and x plus 3. This is x minus 1 into x plus 3. This is x plus 3 into x minus 3. You can cancel this out. And if you put 1, then it will be minus 2 upon. Okay, again, it is a problem, right? So it is x minus 3 upon x minus 1. Now how to solve this? Yeah, it's not 0.0 form. So like why you need 0.0 form? Yeah, for L'Hopital rule, we need 0.0 form, but we are not applying the L'Hopital rule, right? Now from here, how to solve it? I think limit does not exist, right? Yeah. So here, x as this is minus infinity actually. So limit here does not exist. Okay, this is the first question itself. You are getting minus infinity, but that's okay. Have you understood this? So what we are doing, we are just factoring out, and then we have observed that okay, limit does not exist here. Why? Because if you put, I mean, there is no way to solve this simplification form, and if you put x equal to 1, then it is coming out to be infinity, right? And if you put, I mean, they are asking about 1 plus, then actually like, which means 1 plus means 1 plus means they are saying that put 1 plus h. So 1 plus h minus 3 upon 1 plus h minus 1. Limit h tends to 0. So it is h minus 2 upon h. If you put h equal to 0 here, it will be minus 2 upon 0, which means it is minus infinity. Right? It is minus infinity. Okay. So I hope that is okay. Now let's just go to the next question. So here again, they're asking about this limit. Can you solve it? H cube plus h minus 1 cube plus 1 plus h. Okay. Yeah, it's a good idea to expand, I think, h minus 1 cube, right? Actually, there are no certain formulas. Like you have to just see that what can work with you. So here, I think it's a good idea to expand this h minus 1 cube. Do anyone remember the formula? A plus b cube. What is the formula? Yeah, this is not 0.0. Yeah, we cannot use L'Hopital rule here. Okay, this is not 0.0, neither it is infinity upon infinity. We can use L'Hopital rule only when it is 0.0 or infinity upon infinity. Okay, this is AQ plus BQ plus 3AB into A plus B. Is this correct or? Okay, cool. So you can just open this up. Sorry, yeah, it is 0.0. Yeah, it is 0.0. Yeah, it is 0.0. You can apply, but let's see how they have solved it. They have actually expanded it, and then you can take this H common. This is just one way, but you can definitely apply the L'Hopital rule. It is 0.0, so you can apply. Yeah, sorry about it. Okay, if you apply this, then you can do it. You can differentiate it, and then you can get the answer. Are you getting the same answer if you apply? 3. Okay, cool. Let's solve one more question. So I hope you can solve this also. This is again 0.0. So you can apply L'Hopital rule again. Okay. So here also you can apply L'Hopital rule. Let's just see how they have solved it. They are just doing the factorization and solving it, but you can apply the L'Hopital rule. Yeah, either it is 0.0 or infinity upon infinity. Then only you can apply L'Hopital rule. Okay. I mean, if let's suppose this is the case where x going to 0, x going to 1, then since this in this case this is not 0.0 or infinity upon infinity, so the answer is actually minus infinity. But if you apply the L'Hopital rule, it will say the answer is 1, right? If you apply the L'Hopital rule, then it by mistakenly you will get the answer is 1, because it will be just 1 upon 1, something like that, and then you will say answer is 1. But here the answer is minus infinity. Okay. So do you want to solve this question using L'Hopital? Okay. So this will be 3 into, if you differentiate this, this is 3 into h minus 1 square, right, upon 1. So now the answer will be 3. Okay. सही है ना? h equal to 0. हाँ. Okay. Now let's just solve this. This question is again 0.0. So you can apply L'Hopital, right? You can apply L'Hopital. This is 0.0. So this is 1 upon x divided by 2x, which means 1 upon x, 1 upon 2x square. Now this is 1 upon 2. Okay, just try this. This is 1 upon infinity, right? Sorry, 1 power infinity. What is the answer you are getting here? So these are all standard universities question. I have taken this from, I think most of the question are from, Berkeley University. So anyway, like these questions are not very special. So it is okay, like from wherever we have taken it. But yeah, these questions are some standard university questions. So what is the answer you are getting here? Limit x tends to 0. I can say e power 1 upon x into cos x minus 1. If you put x equal to 0, then this is 0.0, right? Anyone getting answer or not? Yeah, this is a good question, right? I think this is a good question. See, here you are getting 0.0. Here you are getting 0.0. Since you are getting 0.0, you can write it separately and you can solve it. So this cos x means sin x differentiation, and then this will be 0 upon 1. So x at x equal to 0, it will be just 0. So at x equal to 0, this quantity is just 0. So that's why this is 1. Cos x differentiation is sin x, right? Or minus sin x. Okay. So, okay, cool. But the answer will be just 1. Cool. Okay. Let me just check it. So how they have solved about it, basically, let me just check their method also. Okay, they have taken the log and all. So they have went through the lengthy approach, which means they have not used the like the shortcut, which means you can rewrite it as e power something. They have done it, but using the derivation that we did it, right? Okay, you don't get it. Let me just tell you. See what is happening here. This is the question. Since this x equal to 0, this is going to 1. This is going to infinity. Since it is 1 to infinity, that's why you can rewrite it something like this. Right? Now, okay, Saurabh kuch zyada ho raha hai. Saurabh is saying that they were not lucky because they are not, they don't have Sachin sir. Okay, this is Berkeley University, by the way. So limit x tends to 0. Now, what you can do, you can take this limit inside, which means e limit x tends to 0, 1 upon x into cos x minus 1, right? And then now you can observe that here it is, if you put x equal to 0, this is 0 upon 0. Since this form is 0 upon 0, then you can solve it separately. If you solve it separately using the L'Hopital rule, which is cos x minus 1 upon x, and then you differentiate it, it will be minus sin x upon 1. And then put x equal to 0, it will be just 0. So this individual quantity is just 0. So that's why the answer is limit x tends to 0, e power 0, which is 1. Okay. What we did, we just solved this individual quantity, this quantity separately. Because you can take this limit inside of anything. Either it is composite function or anywhere you can take this limit. Okay. Twinkle, is this okay now? Okay. Just let me know anyone if you have not got it. Yeah, I understand that this is a little tricky question. If there is any problem, just let me know. Okay. Now let's solve this question. Find the following values from the graph fx. If does not exist, then write do not exist and dne. You don't need to write the region. Okay. So they are saying fx at minus 1 plus. Are you able to visualize it? Or let me go to the next. Okay. Now tell me, what is this A? A is saying minus 1 pay. If you go from this side, minus 1 plus. No. See, if you are going from the, if you're coming from the right side, if they're just saying minus 1 only, if they do not write plus, then they mean that you come from the left side and right side both. But if they're specifically saying that you are coming from the right side, then it means it exists, right? Sorry, where is minus 1? Yeah, if you're coming from the right side, then this is actually 1. You're getting my point? See, here, yeah, it is 1. Like I was just confirming. Okay. So why it is 1? Because they have specifically said that it is plus, which means you only come from the right side. So this is minus 1. At this point, you come from the right side. What do you see? You see that it is approaching to 1, right? The value is approaching to 1. Now at 0, you come from the left side. Okay, if you're coming from the left side, is this defined? What is this answer? It is defined, right? This is 0. Yeah, this is 0 because you're coming from the left side, which means you are talking about this point. Is this okay to everyone? These two particular questions are okay or not? How we are solving it? Okay. Now, if you're coming from the right side at 0, then is it defined? I think it is 1, right? At 0 itself, it does not exist. Function value at 0. This is not the limit. This is just a function value. The function value at 0, they have not actually put any dot here. Okay, if they could put the dot here, then it is 1. If they could put the dot here, then it is 0. If they're not putting dot anywhere, it means it does not exist currently. At 1, let's talk about 1. If you go from the left, then it is, I think, approaching to 2. 2. If you go from the right, it is approaching to 2. At 1, it does not exist, right? No. Yeah, it exists, right? Okay. So at 1, it exists. So, and what is this? What is the value? It exists, and what is the value? No, at 1, it is 2. This is x approaching to 1. This is 2. X minus x plus, it means that it is 2. Like both has to be equal. Like this particular quantity means that this is equal to 1 minus 1 plus, and which is 2. But the value of f1 is actually 1. The value of f1 is 1. Getting my point? If you're coming from the left or right, it is approaching to 2, but on that particular point, it is 1. Okay. And now what about this 3 minus? Which means, yeah, you are coming from the left. It is e.g., I think it is 1. So 100, sorry, 101 dne dne 22211. 101 dne dne 22211. Okay. So these are the answers. Okay. You can see the answers here. Yeah, these are the correct answers. F3 is 1. F3, yeah, F3 is also 1. This is given. Okay. How we get F? 1 minus. If you're going from the left, if you're approaching to this one from the left, then you are seeing the 2, right? This is 2. Okay. Let me explain this again. So see, if you are coming to this one, from the left, then which value this fx is approaching? Which value this fx is approaching? Can you tell me? So you are asking about this, right? One from the left, this f. So just tell me, if you are going to this one from the left, then it is actually 2. From the right also it is 2, but at the 1 it is 1. At the 1 it is 1, right? F1 is 1. The value of the function is 1, but the limit at 1 is 2. That's very interesting. Okay. If given this graph, if someone asks you the limit that x tends to 1, fx, then this is 2, but f1 is 1. This is interesting, right? Okay. Let's solve this question. They have given this graph, and then they're asking this. So maybe I can copy the same graph here. Okay. Yeah. Okay. Can you solve this in homework? Yeah, this is a nice idea because we have the answers on the next page. Okay. Just solve this in homework. Okay. Now let's just solve this question. In this question, they are saying evaluate this limit. Just check whether it is 1 power infinity or not. Yes, this is 1 power infinity. Can you solve this? Okay. So just take all of these as homework. Okay. So we have few questions now, and just take all of these as homework. Okay. So there are many questions we have now. Now let's just solve the gate PYQs instead of solving them. So all of the questions are followed by the solution. So you can see the solution later. Now let's just directly solve the gate PYQs. So there are I mean, like few questions. Let me just count the questions. Okay. 7 questions, 35 and 50. Yeah, almost 7 questions. There 7 questions, 7 or 8 questions there are. So these just take them as homework. Let's just now solve this question. So what they're saying, that find the value of this limit. Now let's just see. If you put x equal to 0, then what you're getting? You're getting 0. This is 0, 0.0, right? So this is a 0.0 form. You can apply the L'Hopital rule, I think. Okay. So what you can do, instead of directly applying the L'Hopital rule, is there any other idea here? See, I mean, there is no formula, like, I mean, there is no algorithm. You have to just apply the hit and try. Yeah. So it seems like we can separate them. It is better, right? So maybe I can go to the next page. Let me just try separating it. See, this X will get cancelled out, right? This is -1. This is -1, -2 upon X. That's fine, right? So finally you got e power X -1 upon, you can write it cos X -1 plus 2 upon X. I mean, ये minus, नहीं, sorry. This is minus. Okay. And here limit X tends to 0. Now let's just try solving this from here. This is, see, this is something minus infinity. What you can do, maybe, like I'm just saying it, maybe you can just simplify this particular form only. Prashant, how you solved it? So e power X -1 upon X is actually 1, right? So you can multiply by the X both side. So basically it will be limit X tends to 0. So this particular quantity is actually 1, right? So you can say it is X upon 1 minus cos X minus 2 upon X. Right? Okay. This till now we have simplified it. Now, do you have any formula for 1 minus cos X upon X? I don't think there is any formula, right? Sin X upon X is a formula. Okay. So what to do now? Any idea? From here, how to proceed? Anyone? This is any idea, like that's very simple. You should be telling me immediately. Clubbing both of this, right? I mean, whatever it is, so minus infinity or something. So I think we should be clubbing it. Okay. So let's just club both of this. This should be X square minus 2 plus 2 cos X upon X into 1 minus cos X. This is limit X tends to 0. Now you can check this is, if you put 0, then this is 0 upon 0, right? This is 0 upon 0. You can apply the L'Hopital rule. Okay. There is a formula that sin X upon X is 1. Do we have also the standard limit as cos X upon X? I don't think, right? So cos X upon X का कुछ नहीं है ना? Okay. Okay. So I think from here you can combine it. Let me just see the solution. Okay. In the solution, they have applied the L'Hopital directly, but you can do in any way. Okay. Now you can apply the L'Hopital. So basically, we have just simplified it a little bit before applying the L'Hopital. So I'm saying there is a formula 1 minus cos X upon X, that is 0. Is this? Okay. Anyway, like I don't remember the formula if I told there. It is something like this. Cool. Yeah, I don't think this is a formula. So anyway, you can do it now, now, or like I'm skipping it. Okay. Now let's just solve this. X minus sin x upon x plus cos x. Twinkle, what is this rat? Oh, rationalization. Cool. So here what you can do, x minus sin x. First of all, tell me, is this any 0 upon infinity, infinity minus infinity, like any form? Which form is this? See, whatever value you put inside the sign, this value is always less than 1, right? So it is always finite. So infinity upon infinity, this is right. This is infinity upon infinity. So maybe you can directly apply the L'Hopital. This is 1 minus sin x differentiation is cos x, right? So 1 minus cos x upon 1 minus sin x. Okay, sorry. 1 second. Yeah. So that is correct, right? Sin x differentiation cos x, and cos x is minus sin. How can I forget this? Okay, just tell me this. This is cos x. Okay, and cos x is minus sin x, right? Cool. Yeah, that is correct. That's what I'm saying. Okay. Now from here, how to proceed? Mhm. Is this any form? X tends to infinity. This is not even any form, right? You don't know this values and you can't say anything. Okay. Okay, x कॉमन लेने से क्या फायदा है? This is 1 minus sin x upon x. No, x is infinity here, right? If that is x is 0, then only that formula is there. I mean, as x is infinity, in that case, it is 0. That's what you're saying? Sin x upon x? Okay, okay. Yeah, right. Right. So we can solve in that way. Maybe we can solve in that way. Okay. So what we can do, we can take x common from here, and it will be limit x tends to infinity 1 minus sin x upon x. Yeah, it is easy in that way, right? 1 plus cos x upon x. Now you put x tends to infinity. This is a finite number, which is less than 1. So this is actually 0. This is also 0. So the final answer is 1, right? Okay, cool. You don't need to know all of this skewish theorem and all. So you can directly see from here directly. Okay. Okay. Now let's just go to the next slide. So can you solve this question? X tends to infinity. This is 1 power infinity. I think this should be solvable, right? So you can do it as an homework. This is infinity power 0. Okay. This is interesting. How to solve this? Let's just take log. So this quantity is basically, I can write x power 1 upon x. Okay, I can apply the limit later. Okay, later I will be applying the limit. So let's suppose this is L, then log of L is basically 1 upon x log x. इससे फायदा क्या है? L is e power this. Okay, L is e power 1 upon x log x. Now, if you put x tends to infinity, then this is infinity upon infinity form, right? Okay. So what you can do, you can put limit x tends to infinity. This inside this quantity is nothing but e power 1 upon x, or you can say log x upon x, right? Log x upon x. Then this is infinity upon infinity form. Since this is infinity upon infinity form, you can say this is 1 upon x, right? And then you put infinity, then final answer should be 1. Is this okay to everyone? See what I'm saying, that have you understood till this point how we are rewriting it here like this? Okay, this is just a rewritten. I mean, you can write this quantity x power 1 upon x as e power log x upon x. Okay, I mean, this is L, and L is nothing but e power log x upon L. That's how we are writing. This is L. And if you take log and then you put it in the power, it's something like this. So basically, I wanted to solve limit x tends to infinity, x power 1 upon x. But I'm saying this is same as saying I can solve limit x tends to infinity, e power log x upon x. Now, since it is infinity upon infinity form, you can apply the L'Hopital rule here, which means this is 1 upon x and this is just 1, right? So basically, this is limit x tends to infinity, e power, if you apply, this is 1 upon x, right? And then this is infinity, and then it means this is 0, this is e power 0, which means it is 1. Okay. So can you also see little intuitively that why this is coming out to be 0? Why this is coming out to be 0? Little intuitively, can anyone tell me? I mean, this is finally 1 upon x, which is coming out to be 0, right? So what I'm asking is this. Intuitively, like I'm just asking you intuitively, can you tell me limit x tends to infinity, log x upon x? You can solve it, but intuitively, can you tell me why this is 0? No. Like, sorry, I was about to write Choco Star, but okay, it is Twinkle. So Twinkle is saying that this is 1 upon x into log x, right? And then this, since this 1 upon x is actually 0, that's why you can say 0 into log x is 0. No, that's not the correct argument. Why? Because this is 0. This is not 0 into constant. This is 0 into also infinity. Okay, this log x is also infinity, right? So this is not the correct argument. That you can't say that that this is a correct argument. This log x is also infinity. So it might so happen that, I mean, it might so happen. See, this is not the perfect 0, right? This is very small number. It might so happen that this is very small number. And this could be extremely large number. And since this is very large number, if you multiply by the very small number, you can make very large number, which means if this is 1 upon x into, let's suppose, x cube, can you say this is 0 just because this is 0? Can you say this is 0? 0 into x cube if x tends to infinity? No, right? This is actually infinity. This is not 0 into x cube. That's how you can't make it 0. Have you understood this? So this is 0 into some function. Okay. Just don't take it as a constant. This is some function. So that's why you have to be careful. Yeah. So why it is 0 intuitively? Because as you know, as we have also seen in the fundamental, that this log is actually very small number, which means if you say 2 power 30 or maybe 2 power 100, If let's suppose x is this, if x is this, then log x is just 100. Now you might say that, okay, what's the difference between 100 and 200, right? What's the difference? Like, not a big deal, 100 and 200. What's the difference? So maybe let's suppose you are right. What about this? 500 and 2 power 500 and 500. Okay. See, this 2 power 500 is so large number that I think if you even start counting the number of digits in 2 power 500, then maybe it will take some years just to count number of digits. I mean, it depends on how fast you are counting, obviously. But yeah, you can understand like this. So basically, it is extremely huge number. Okay, this 2 power 500. And since it is very small number, compared to x, I'm saying compared to x, it's all about the comparison. Compared to x, this is very small number. That's why you can say just almost like constant, okay, which is 2 3 or something like that. Compared to x, that's why this is some constant upon infinity, which is 0. Anyway, cool. So yeah, that's how you can solve this question. Now let's just come to this. The value of this, they're asking, this is infinity power e power minus infinity 0, right? Infinity power 0, something like this. Why it is 0? Because log x upon x, limit x tends to 0. Why it is 0? Because it is very high number. Sorry, limit x tends to infinity. This is very high number. This is actually infinity. And this is, as I said, it is function. Generally, it is function. But since it is very small compared to x, that's why you can say this is just constant. So this is 1 upon infinity, basically. Okay, which is 0. Otherwise, like in general, you can't say it is a constant. Basically, let's suppose if it is x cube, then it is x cube upon x. It's not like 1 upon x into x cube is also 0. Okay, it's not like that. If x is infinity, then this is infinity. This number is infinity. Okay. So how to solve this? I think you can write it in the same way. E power log base e. Okay. 1 plus x square into e power minus x. I mean, any number you can write in that way, right? Provided that number is positive and all. But here, since x is going to infinity, so it must be positive. Okay. Now, this is e power minus x is in power. Okay. So basically now you got it is in multiplication. If you put x tends to infinity here, then this is infinity into 0. Okay. So now finally can you solve this separately? Limit x tends to infinity log 1 plus x square upon e power x. Can you solve this separately? Okay. Let's suppose this quantity is whatever is this quantity, then finally you will make it e power, right? To get the final answer. So what is this quantity you're getting? This is infinity upon infinity. Again, I think this is just constant. X के आगे constant है, तो e power x के आगे तो I mean must be like almost constant. So this is huge number, extremely huge number. Okay, and this is very small number. So I think it must be 0. Even if you apply the log L orbital rule, it should be 0. Is this 0 या रहेगा? I mean, you should be confirming. Okay. So e power 0 is 1 basically. So finally the answer is C. Intuitively also, have you understood that why it is 0? Because the way this log x square, okay, doesn't matter. This is 1 plus x square. It doesn't matter. This is 2 you will take outside anyway. Okay, see, this is log of 1 plus x square, right? Upon e power x. Okay, let me give x square as free of cost to him, which means instead of 1, let me even if I write the x square here, it is 2x square, right? So you will take the, I mean basically you can take this 2 outside somehow. I mean, I hope you are understanding. This 1 doesn't matter first of all, because it is x square itself is very huge number. So 1 plus some huge number doesn't matter. So it is just x square. You can take 2 outside. It is actually just log x. Okay, just don't get afraid by this x square. So intuitively you can say log x upon e power x is actually 0. Why? Because this is very, very small number compared to this e power x when x tends to infinity. Okay. Cool. So 1 is the correct answer here, right? So what you can do, you can just go to the gate overflow, and on the gate overflow, you can write these kind of things. You will get many upvotes. I'm sure about it. Just write these kind of things. There's intuitively also this quantity is 0, and just explain why that is the case. Okay. And then within 1 year, you will be famous. So these are the small things. Just write on the gate overflow. I mean, it is actually just helpful for the others also. See, I cannot write it because I mean there are too many things that I have to do. But as an aspirant, I'm just telling you. Okay, you can write it, and then it will be a good discussion. So see, if as I already told you that if you want to be very popular on the Gate Flow, the only way, like one of the best ways, is basically that you contribute on the Gate previous year questions. If you're contributing on the Gate previous year questions, then you will be a little more famous, right? I mean, you should be contributing on the weekly quiz and these kind of questions also. But if you contribute on the PYQs, you will be famous faster. Okay, so let's just see this. This is, I think, 0.0. This is a good question. Can you solve this? So see, can you relate this with the standard limit? So standard limit says that limit x tends to 0, sin x upon x. This is 1. Which means they are saying that these two quantity must be same and these two quantity must be going to 0. So these two quantity must be same. These two quantity must be going to 0. So that's why this is just 1. If you want, what you can do, you can replace this x tends to 4 by, I mean, by, you can say this is x equal to, you can say 4 plus h. Okay. And where h tends to 0, you can do something like this, or 4 minus h, something like this. Okay. Where h tends to 0. So if you do 4 plus h, you will be getting left hand limit. If you do 4 minus h, you will, sorry, if you do 4 plus h, you will be getting left hand limit. If you do 4 minus h, you will be getting 4 plus h means right hand limit, 4 minus h means left hand limit. Okay. You can do both. You will be getting the same answer as 1. Yeah, you can also apply the L'Hopital rule. Yeah. Okay. So there are many ways to solve one question. Cool. By the way, this is just a standard limit. Has everybody understood that this is a standard limit? Okay. One of the person is asking in the private chat that Rehan Dishu, that he has completed half of the linear algebra and joined very recently. So should he be continuing with the C programming? You can just message me on the Telegram, okay? And then I will be just resolving it out. Okay. Now, let's just solve this. Can you solve this question? I think this is also easy question, most probably. You can take common, right? This is x power 7 common if you take. Okay, instead of doing all of this, maybe this is 1 minus 2. You can directly apply the L'Hopital rule, right? Okay. Again, for this question also, you can apply the L'Hopital rule. Actually, in the gate, they just ask the easy questions only. For this question also, you can most probably, you can apply the L'Hopital or not. This is minus 6 plus 22. 22 minus 6 is 16. 4. Yeah, you can apply the L'Hopital again. Okay, because it is 0.0 form. That's why you can apply. Now let's just see the continuity. So have you understood the limit? We have solved all the question of the limit. They will just ask you the easy questions only. I mean, that's how we need to solve these questions. I think only one tough question or one tricky question that was there was this one. Maybe. कहाँ गया वो? एक क्वेश्चन था ना? Yeah, probably you can say it as little tricky. Okay, that's all. I mean, otherwise every question was easy. Cool. So now let's just see the continuity. So basically, continuity and limit are almost same. There is nothing to teach here, to be very honest. You just have to check whether the limit exists, which means that whether the left hand limit is equal to right hand limit, and then they will extra give you one more information about the function. That's all. So in the gate PYQs also, there is no specific, I mean, there are one or two questions probably, but there is no specific question from the continuity. The questions are relating to the, I mean, mean value theorem, Rolle's theorem, or like that. So I don't think I have even the questions of the continuity here. Like you can just try out the questions, but specifically there is just one or two questions that we have, I think, solved in our those videos itself. Let me just check. गेट पीवाईक्यूज में भी इस टाइप का एक दो क्वेश्चंस है, यू कैन जस्ट ट्राई दोस, ओके, एंड वी हैव सॉल्व दोस क्वेश्चंस, these type of questions in the videos also. So continuity is this is not a different topic, that's what I'm saying. This is not a special topic, this is just a limit. Okay, they will also give you one more information. So there is not extra information, like extra thing that I need to teach here. The only thing that I can teach you the definition. So basically continuity says that function is continuous if you're approaching from the left, you're approaching from the right, and the value of the function, everything is same. Now in this case, is this function continuous? In this case, is this function continuous? The answer is no. Why? Because when you are approaching from the left, approaching from the right, this is okay, but at that particular point the value is not continuous, right? No, it's not empty, it is basically one dot. No, fa is defined, fa is this particular value. So you can say that limit a minus is same as limit a plus, but it is not same as fa. No, empty means this, I mean, this is not in the continuity. The value of fa is, let's suppose this is 2. So fa is 2, and let's suppose this is 1. So these values are 1, and this value is 2. Okay. Yeah, so you can solve those examples, and also if you have tried the gate PYQs, then also you might have got the idea. So these examples are good. Yes, I agree. I think there was some calculation mistake in this, right? Were you able to solve that? So here, instead of multiplying by minus h, I should have multiplied by this. So you can solve it, right? Okay. Now let's just talk about the differentiability, which is most interesting topic. So should I tell you now, or should we take a break? Let's just continue for half an hour, and then we can have a break. Okay, cool. Maybe we can continue for half an hour. As in, nahi. Actually, like today, I just wanted to complete the half an hour of this topic, and then there is a different topic which is maxima and minima that I wanted to cover tomorrow with the integration, if that is required. Okay. So let's just see one definition of the differentiability, that how to define this differentiability, and then we can stop. Cool. So first tell me, do you recall there is one definition of the slope? If let's suppose that 2 points are there, then can you tell me what is the equation of the line passing from 2 points? Okay, passing from 2 points. Y equal to mx plus c is basically when you know the slope and you know the intercept, right? So actually, I also don't remember exactly, but I think it is something like that. Y minus y naught equal to the slope into x minus x naught, right? I mean, this is, let's suppose, y1. something like that, right? I don't remember exactly, but something like that. We can also drive. Anyway, so basically, like there is a formula of the slope, which is something like this. No, again, Jirin, whatever you are writing, basically the C is unknown here, right? I'm asking passing from 2 points. You like I mean that is fine, but you again have to find out the value of C. This is mx plus C. Can anyone tell me how to find out the value of C here? How to find out the value of C? By putting any of the value, right? Either x1, y1 or sorry, yeah, x1, y1 or x2, y2. Okay. Cool. So basically, you can say that if you have 2 points, then you can find the equation of a line passing through that, or you can also find out the slope of that line. And what is that slope? If let's suppose the points are here a comma fa means this is on the function, so the by coordinate is fa. And similarly, let's suppose this is x, any random x, and this is the by coordinate is fx. So is this fine to everyone that we have this slope for this line? This is the slope for this line, right? Okay. Now, suppose if I say that the points which is A and X are too close, which means they're not that far, then this what we call it secant, right? So this secant becomes a tangent, which means currently, okay, first of all, have you understood that what I'm talking about? See, here, what I'm saying is this: there is a point A and there's a point X. X could be B or something. If you mind writing X, then you can write B. Okay, doesn't matter. Now there's a point A, there's a point X. Now on this curve, if I say that A, then this is the corresponding y coordinate will be FA, and here the corresponding y coordinate will be FB or FX, whatever it is, right? Now if you write the slope, I'm just writing the slope. This is a slope equation. If you write the slope value, then it will be y2 minus y1 upon x2 minus x1. Do you recall how to find out the slope? How to do it using the, I mean, I think you can do it. That's very easy. Maybe I can just tell you. Yeah, tan of the triangle. So see, let's suppose I want to find out the slope of this equation. Okay. This is, let's suppose, A. This is, let's suppose, x1. This is, suppose, y1. This is, let's suppose, x2. This is, suppose, y2. I want to see that what is the angle of this. I mean, this tan theta, that is also called tan theta. So क्या करना है? This is x1 minus x2. This is y1 minus y2. So what we can do, I can take this as a triangle. This is y2 minus y1. This is x2 minus x1, right? I want this angle. This angle is perpendicular upon base, right? So this tan theta, do you recall it? If you don't recall it, it's fine. I mean, it's not necessary. So tan theta is perpendicular upon base. So that's how you can find out the slope. Okay. I mean, if you can recall it, it is okay. Otherwise, don't worry about it. How many of you are not able to recall, or how many of you are able to? Okay, just tell me how many of you are able to recall. Okay, so tan theta, I mean, at least the tan theta, you know, right? The tan theta is actually, I'm from the Hindi medium. Anyone, are you from the Hindi medium? So I remember, I used to remember in this way. This is lal bate ke kakka. That's how I used to remember, which means tan theta is lamb upon adhar. Lamb means this is perpendicular upon base. Okay, so yeah, so from the English medium, they call it Pandit uh, Pan, okay, Pandit Badri Prasad Harar Bhole, right? Pandit Badri Prasad Harar bole. Yeah. Okay. Perpendicular and base. These formulas. Okay. So this is how you can find out the slope. Now tell me, this this particular thing is line or this is just a slope? This is just a slope, right? This is not the equation of any line. This is just a slope. Okay, so this should be clear to everyone. Now, like we are building the definition of differentiability from very basic. So basically, now you know that how to find a slope given a line. Now, what we are going to do, we are taking the points on the curve. Okay, we are taking 2 points on the curve, which means now the bi-coordinates will be some form of f, fa and fb. So now we know that what is the slope of this particular line. This particular line has this slope. Okay. Now what we are going to say that instead of taking these two points so far, instead of taking these 2 points so far, let me take these two points very closely. So which means instead of taking these 2 points so far, let me put them very close. So what was the answer earlier? Earlier answer was y2 minus y1 upon x2 minus x1. Now let's suppose that currently my x1 y1 points and x2 y2 points are something like this. x1 y1 is AFA, x2 y2 is actually a plus h or a minus h, doesn't matter. Okay, so I'm taking this point which is a plus h, doesn't matter. Okay. This is a plus h, comma. Can anyone tell me by 2? F of a plus h. Okay. So is this clear to everyone? So I'm taking 2 points which are extremely close, which means this is just h tends to 0. So now tell me the slope. What it will be? y2 is, let me write the slope. y2 is f of a plus h minus f of a upon a plus h minus a, right? Where h tends to 0. So this is the slope of 2 points, I mean of a line which is joining 2 points which are extremely close. They are so close that we are calling it tangent. I mean these are not even the 2 points, where which means we say that h tends to 0. Is this okay to everyone? Okay. So I say that slope of this time, instead of calling it secant, I'm calling it tangent. Tangent at a point a comma fa is something like this. Okay. Cool. Is this okay to everyone? Or there is some doubt here? So this is slope of a tangent. Okay. Now basically what is happening here is that what we are doing, we are let me tell you using some function. So suppose there is some function which is x square plus 1. Now how we are finding the slope is basically we are taking the I mean let's suppose I want to find a slope of this line, okay, of this line which is again a secant, okay, not a tangent, just a secant. So basically if I want to find a slope of this line which is passing through these 2 points, then can you tell me what is the slope? This, I mean this by difference which is del y1 upon x difference del x1. Is this okay to everyone? So this is a slope of this line, but let's suppose these 2 points are extremely close. I mean these 2 points are extremely close, so I will say that this is a slope at this point. Okay, instead of calling it that this is the slope of a line passing through 2 points, I'm saying this is slope of tangent at this point, where this del y1 and del x1 are in the neighborhood. I mean I'm finding out using the neighborhood only. Okay. Now here similarly, suppose I find out slope at this point, it will be what? it will be, let's suppose this is, okay, this is y1, x1. Okay, the slope at this point will be del y2 upon del x2. Just imagine that del x1 and del x2 are same, which means the x distances are same. Then can you tell me which slope is greater? Y1, this point, let's suppose point A or point B, which slope is greater? If let's suppose del x1 and del x2 are same, as you can see that del y1 is greater than del y2, then slope as A is greater or slope as B is greater? Slope as A is greater, right? At A is greater. So basically, this slope is greater because this function is increasing rapidly here. Okay. If you increasing means what? If you increase the value of x, if you increase the value of x from here to here, you increase the same amount of value of x, but the by got increased too much, right? Compared to this particular point, you increase this x and by got increased just little, but you increase this much x only, right? Same amount of x, but by got increased too much. So that's what we say, that this here at this point, the slope is steeper. Why it is steep? Because the function is rapidly increasing. I mean, slope is higher means what? Function is increasing. Function is rapidly increasing, basically. Okay. I will come to these points maybe in a while. Before that, let's just argue one point, is that if function is increasing, then slope is positive. Okay. Let's just argue about this point, that if function increases, then slope must be positive at that particular point. I mean, see, we always talk about at particular point. No, that's always true. If function is increasing, then slope must be positive. Okay. So we always argue about a particular point. So I'm talking at a particular point if the function is increasing, which means let's suppose here, let's suppose I talk at this point. Here, let's suppose this is the function. Here, tell me function is increasing or not at this particular point, which means if you go in the neighborhood, if you go in the increasing at this particular point means what? If you increase the value of x, is the y value increasing or not? If you increase the value of x, see, if you increase the value of a little bit, then isn't y value increasing? Y is also increasing, right? So we say that, I mean, I will just mathematically prove this, that if the function is increasing, then slope must be positive. But currently I'm just telling you one thing, is that here what is happening, that if we are seeing in the neighborhood, which means if we are increasing this x, this x, it means what? If you're increasing this x, y is also increasing. But you can say that, see, you are increasing this x, let's suppose this much, but you just found out that y got decreased. I mean, you are increasing the value of x, but y started decreasing. See what I'm saying, that if you're increasing the x, y is still decreasing. So can you say the slope is negative at this point? But y is decreasing if you're increasing the x, right? See what is happening, what I'm trying to convey is that, yeah. So what I'm trying to convey is that whenever I say that the function is increasing at this particular point or not, we always remain ourselves in the neighborhood. It must be clear to everyone that we are always in the neighborhood. We will always talk about s tends to 0. Okay. We are not predicting the future. We don't know about the future. We always talk about the neighborhood. That must be clear to everyone. Okay. Yeah, very close. So let's start from very basic. Let's first define the differentiability, that when we say the function is differentiable or not, and then probably, sorry, like I just wrote it, but then I just got to remember that we first have to define the differentiability, because actually we have done it in the videos. So that's why I forgot to do it. So, but let's just first define that when we say the function is differentiable, then we can talk about this. Okay. So maybe we can take a break and then we can continue later. So, or I can just define the differentiability. I don't know. Should I be taking the break? See, now you are getting a little bit idea. Basically, I want to teach this differentiability in very, very crystal clear way. Okay, so here I'm just jumping a little bit here and there, but I want to do it in a very clear way, that what is this differentiability, what is this f double dash x and all. So maybe we can start in a new video. Okay, and today I don't have the all the slides for maxima and minima. I just have few slides only. So either we can just cover 1 hour of today, or we can start from tomorrow itself. So what we can do, maybe we can just start this differentiability tomorrow. Okay, and we will make sure that you understand everything, which means that from the basic definition of differentiability to everything, like intuitively, that what is this f double dash x, what is this f dash x, and everything. Okay, with the diagrams, I have the good diagrams here. Okay, I will share the share those diagrams tomorrow, and few of those diagrams I've actually made because I was not able to find those diagrams over the internet. I mean, based on my thinking that okay, I wanted something, and those exact same diagram I was not able to find, so that's why I made those diagram by myself. Anyway, so let's just do one thing. We can start this differentiability tomorrow. Okay, cool. Thank you so much. Thank you, everyone.